Today we're going to move on to the second part of our unit, and we're going to be looking at factoring. In today's lesson, we're going to be looking at common factoring and factoring by grouping. Let's get started with our learning targets. By the end of this lesson, you should be able to use algebra tiles to model the factorization of a trinomial. You should also be able to factor by removing the GCF, or greatest common factor, and you should be able to write a polynomial in factored form. Now, in a previous lesson, we looked at how to expand polynomials using algebra tiles. Now we're going to do the reverse process. So instead of being given the factors and working towards the product, we're going to have the product and we're going to look for the factors. So in our first example here, we have x squared plus 4x, which is modeled in the inside piece here. That would be our area. And we want to find the factors, which would be essentially our side lengths. Now to get x squared, that would be x times x. Notice that my length for my x is the same length as my x squared. So x by x would give me x squared. And to get a 1x, that's going to be x times a positive 1. And since I have 4 x's, I'm going to have 4 1's. So to write my algebraic statement, I would have x squared plus 4x equals x times x plus 4. Now, if I wanted to check my work, I could do that by expanding. X times x is x squared, and x times positive 4 is positive 4x. I could also check by doing substitution. In my next example, I have 2x squared minus 2x. Notice again I have an x squared, so that's going to be x times x. And then I have another x squared, so that's going to be x times x again. And on the bottom here, I have a negative 1x. Since this is a positive x, I must be multiplying by negative 1. Again, remember, it's always important to do your legend. So a shaded is positive and an unshaded is negative for my examples. If you choose to use a reverse legend, totally fine. Now for my algebraic statement, I would have 2x squared minus 2x is equal to 2x times x minus 1. And if you wanted to write that as x minus 1 times 2x, that would be acceptable as well. Now, both of these examples relate directly to what we're going to be doing today, which is factoring by pulling out a GCF. If you notice, we have x squared plus 4x. In both of those terms, I have a common variable, which would be x. If I divide out x, that's my GCF. X squared divided by x would give me x, and 4x divided by x would give me 4. I refer to that as my leftovers. Not exactly a mathematical term, but it's a good way to remember. Notice also that my original polynomial had 2 terms. My leftovers also still have 2 terms. For the second example, I had 2x squared minus 2x. Notice that both have a coefficient of 2, so I can divide out a 2. And there's an x squared and an x. The largest x value that I can pull out of both terms is just x. So I'm going to divide both by x. Notice that's my GCF. 2x squared divided by 2x is x, and negative 2x divided by 2x is negative 1. Notice again, 2 terms in my original, 2 terms in my leftovers. Now moving on, these 2 examples are trinomials. We are not going to look at factoring these algebraically today, but we are still going to look at the algebra tiles. So for the first example, I have x squared plus 3x plus 2. Notice again that x squared is x times x. And to get 1x, I have a positive x times a positive 1 and another positive 1. And then in the second row here, I have an x. I already have the x, so this must be a positive 1. My algebraic statement would be x squared plus 3x plus 2 equals x plus 2 times x plus 1. For our last example, we have x squared minus 5x plus 6. And you'll notice that the product has not been drawn yet, so we're going to need to create that. When we are drawing our product or building our product, it needs to be a rectangle because remember that we are dealing with the area model. So this needs to be a completed rectangle. So I'll start off with the x squared. Now notice in my previous example, my rectangles were both vertical and horizontal. And so the same thing is going to happen here. I have a negative 5x, so I'm going to have to decide how many of those rectangles are vertical and how many are horizontal. As you get more experience with factoring, you'll know what it is right away. But right now we're just doing a little guess and check. So I'm going to start off with 1 and 4. So I'm going to have 4 verticals and 1 horizontal. Now, in order to complete this polynomial, I need 6 positives. Well, I notice that I only have space for 4, so that's not going to work. So what I'm going to do is I'm going to erase one of my verticals and I'm going to make it horizontal. Now I have my 5x's. There will be other examples that come where we might have to draw extra positives or negatives in order for them to cancel out, but we're just going to start with this for now. So now I'm going to put in my 6 positives. Once I have my product, then I can look for my factors. So I have x squared, that's going to be x times x. And I have negative x, so that means I'm going to be multiplying by a -1, and I'm going to have 3 of those. And down here I have negative x, so that's going to be a positive x times a -1. And notice that a -1 and a -1 will make a positive 1. So my algebraic statement will be x squared minus 5x plus 6 equals x minus 2 times x minus 3. Now notice that the -2 and the -3 give me a positive 6, and a -2 plus -3 gives me a -5. So we're not getting into that factoring piece today, but just a little food for thought or a little teaser for our next lesson. So before we get into common factoring, let's just do a quick review of GCF. When we're talking about GCF, that stands for greatest common factor, or biggest number, or in this case variable, that's the same. So when we're looking for the GCF of 2 terms or 3 terms, we want to start by looking at our coefficients and then our variables. Looking at 15a and 25b, I can start by listing my factors. 1 and 15, 3 and 5. 25 would have 1 and 25, and 5 and 5. Notice that the only factor they have in common is 5. So my GCF would be 5. And then I look at my variables. One has an a and one has a b, so they have no variables in common. That means my GCF is just 5. Looking at part B, I have negative 5x squared and negative 20x. When I'm trying to determine my GCF, I will always look at my smallest coefficient. Now I'm not worried about the signs, I'm just looking at the value of the number. In this case, my smallest coefficient is 5. 5 goes into 20, so part of my GCF will be 5. Now both terms are negative, so I'm going to have a negative 5. And then I look at my variables. I have an x and I have an x squared. So negative 5x squared is like negative 5 times x, and negative 20x is like negative 20 times x. Well, notice I can only divide one x out of both of them, so my GCF is going to be negative 5x. Looking at C, I have 12, 20, and 8. 8 is my smallest coefficient, so I'm going to look at the factors of 8, which gives me 1 and 8 and 2 and 4. Well, 8 doesn't go into 20 or 12, so that one's out. 4, however, goes into all 3 of them, so 4 is my GCF for the coefficient portion. Now I look at my variables. I have an a squared, an a, and an a cubed, so I can pull out an a. And then I have a b to the fourth, a b cubed, and a b squared. Now when I'm talking about pulling out, that means I'm dividing out my GCF. So my GCF for this is 4ab squared. When it comes to factoring, the first step that we do in all types of factoring is look for a greatest common factor. This is always the first thing that we do to check to see if we can reduce our polynomial. We're going to take a look at a few examples here, and then I'm going to have you try some on your own. For example 1, I have 2x squared plus 8x. When that's in factored form, I have 2x times x plus 4. Now in order to factor this polynomial, I'm going to start by looking for my GCF. When I look at 2 and 8, 2 is the smaller of the two numbers, and 2 goes into 8. So that's part of my GCF. And then I have x squared and x. X is the largest variable that I can pull out from both terms. So that's my GCF. And then to find my leftovers, I'm going to divide each term by the GCF. So 2 divided by 2 is 1, x squared divided by x is x. Positive 8 divided by 2 is 4, and x's cancel. So this piece would be my leftovers. Notice again that if I have 2 terms in the original polynomial, I have 2 terms in my leftovers. For 5x plus 35, my GCF is 5. So I'm going to divide each term by 5. 5x divided by 5 is x, and 35 divided by 5 is positive 7. So 5 would be my GCF, and x plus 7 would be my leftovers. Moving on to example 3, I have a 7, a negative 28, and a 14. My smallest coefficient is 7. I can divide 7 out of each of those terms, so that's part of my GCF. Then I look at my variables. I have an a squared, an a squared, and an a squared, so I can divide a squared out of each of these terms. And then I have a b cubed, a b to the fourth, and a b. So the most that I can divide out is b. And then I have c to the fourth, c cubed, and c squared. So once again, the most that I can divide out is a c squared. So there's my GCF. Now when I divide 7 over 7 is 1, a squareds cancel, b cubed over b is b squared, and c to the fourth over c squared is c squared. For term 2, I've got negative 28 divided by 7 is negative 4, a squareds cancel, b to the fourth over b is b cubed, and c cubed over c squared is c. For the third term, 14 over 7 is 2, a squareds cancel, b's cancel, and c squareds cancel. So again, I have my GCF and my 3 leftovers. On the right-hand side, I have a number of examples. I'd like you to pause the video, try them on your own, and then come back and check your work. And let's see how you did. For part A, we had 4x minus 18. Now my factors of 4 are 1 and 4 and 2 and 2. I cannot divide a 4 out of 18, so the largest GCF that I can pull out is a 2. Notice that 18 doesn't have a variable with it, so I cannot pull out the x. 4x divided by 2 is 2x, and negative 18 divided by 2 is negative 9. So 2 would be my GCF, and 2x minus 9 would be my leftovers. For b, my GCF was 7x squared y. When I divided the first term, everything canceled, so that left me with a 1. Again, be careful not to just cancel it out and leave nothing. If there's 3 terms in the product, there needs to be 3 terms in the leftovers. 14 divided by 7 is 2, x cubed over x squared is x, and y squared over y is y. Negative 49 divided by 7 is negative 7, my x squareds cancel, and I'm left with a y. For part C, my GCF was 3x squared y. Dividing the first term leaves me with 2. Dividing the second term leaves me with a negative y. And dividing the third term leaves me with an 8x. D and E look a little bit tricky, but they are still GCF examples. Notice that in both of my terms, I have an a plus 4, so I can divide that out. That's my GCF. And then in the first term, I'm left with an a, and the second term, I'm left with a negative 3. So that would leave me with a plus 4 in brackets times a minus 3 in brackets. For E, my GCF is x minus 5. So when I divide that out, I'm left with x in the first term, and in the second term, everything cancels, so I'm left with a positive 1. These last two examples are ones that you'll come across quite often when we're factoring by grouping, or we're using a method called decomposition, which we'll talk about when we look at factoring trinomials. The next method of factoring that we're going to look at is factoring by grouping, and often we see this when we're working with 4 terms. Now, factoring by grouping is not a method that you're going to see or use too often unless you're using decomposition, but there are going to be the occasional times where you're going to come across those 4 factors. It is a polynomial that's factorable, and we can factor using grouping. In this example, we have x squared plus 2x minus 3x minus 6. So we have 4 terms, and what we're going to do is start by grouping with brackets. So we can bracket the first 2 terms, bracket the next 2 terms, and then put a plus sign. So I always say it's group plus. Now our next step is to factor out a GCF from each of those brackets. If you notice in our first term, we have x squared plus 2x, so I can divide out an x from each of those. X squared divided by x is x, and 2x divided by x is 2. In our second bracket, we have a negative 3x and a negative 6. Whenever our first term is negative, we will always divide out that negative. So my GCF is negative 3. Negative 3x divided by negative 3 is positive x, and negative 6 divided by negative 3 is positive 2. What you should notice is that both of your brackets are the same. So if this polynomial is factorable and we can factor by grouping, those 2 brackets should always end up the same. Our final step is just to factor out our GCF again. So notice that we have x plus 2 in both terms, so that's my GCF. And then that leaves me with x and minus 3. So whether you write your final answer as x minus 3 times x plus 2 or x plus 2 times x minus 3, the factors are the same. Let's take a look at a few examples. For part A, I have 2x squared plus 2x plus 3x plus 3. I'm going to start by grouping and adding that plus sign. In my first bracket, my GCF is 2x. 2x squared divided by 2x is x, and positive 2x divided by 2x is positive 1. In my second bracket, my GCF is positive 3. 3x divided by 3 is x, and 3 divided by 3 is positive 1. Now you'll notice as I was doing this example, I didn't show that dividing out of the GCF. As you get more practice with these examples, you may not need to do that anymore, but it's definitely helpful in the beginning. All right, my GCF here now is x plus 1, and my leftovers would be 2x plus 3. For b, I have 3m squared plus 9m plus 5m plus 15. I'm going to bracket my first two terms, bracket my last two, and put that plus sign. In my first bracket, I have 3m squared plus 9m, so my GCF is 3m. That's going to leave me with m plus 3. In my second bracket, my GCF is positive 5. Notice I'm writing that positive sign. And my leftovers are m plus 3. Once again, I'm on the right track because my brackets look the same. So my GCF is m plus 3, and my leftovers are 3m plus 5. Moving on to our last example, we have 6b squared minus 9b minus 4b plus 6. Again, I'm going to group plus. In my first bracket, my GCF is 3b, and that's going to leave me with 2b minus 3. And in my second bracket, my GCF is negative 2, and that's going to leave me with 2b minus 3. My final step is to pull out that GCF, so I'm going to have 2b minus 3, and then 3b minus 2. So today we've taken a look at factoring out a GCF and factoring by grouping. Again, as I mentioned earlier in the lesson, factoring out a GCF is the first step whenever we're factoring. It's one that we tend to have a good understanding of in the beginning, and then we forget about as we move on to other methods. But always remember that whenever you're factoring, the first thing you do is look for a GCF. Make sure to do some practice. Have a great day, and I'll see you soon.